This is AP Environmental Science, Chapter 1, Part 5. I just wanted to make a quick reminder. I was thinking I want you to understand that these videos are short videos that we're just trying to get basic understanding of the chapter to you. But you need to read the textbook thoroughly and take good notes through the text because that's going to give you all the details that I simply just can't spend time on in these types of videos. And so make sure you read the text and take thorough notes. So we'll continue on with human population. Human population is really the core issue to the planet's health. And so depending on human population, you'll see systems on the planet be more or less stressed. And so this is a core issue, and it's one of our environmental indicators. And so depending on the population number, you're going to see a more stressed planet or you're going to see a less stressed planet. What we've seen, well, so the current human population is a little bit more now than 6.8, and it's going to be 7 billion people by the end of 2011. So this year we're going to reach 7 billion people. We'll also do an activity later to show you how quickly this number is climbing. In any given 24-hour period, you'll have more than 300,000 infants born, about 150,000 people die, and then what that makes for is about 212,000 new people on Earth each day, or over 1 million additional people every 5 days. So every 5 days, an additional 1 million people are on planet Earth. And so that means that each and every person within that 1 million in that 5 days requires a certain amount of resources, be it water, air, food, etc. And so that puts more stress on systems. So human population is a huge environmental indicator, and this is really our underlining problem on Earth currently. So the UN project has predicted through mathematical models that there'll be between 8.1 billion and 9.6 billion people on Earth by 2050. And then about 10.5 billion by 2100. And these are sort of mid-range estimates. That means that if birth rate goes down slightly, that sort of thing, that's what we suspect. But if birth rate goes up, which is not expected, you'd see these numbers be quite a bit higher. Or if birth rate went down quite a bit, then you'd see these numbers be lower, although that's not likely. So this picture just shows you a crowded area and how disastrous and messy that can get. Imagine how much trash and pollution comes off of a beach like this, and it's just due to too many people, overpopulation. So because human population has grown, each and every individual requires a particular amount of resources, and so therefore we have resource depletion, which is another one of our environmental indicators. And so this is in order to survive, we have to have resources. And so as human population grows, resources are increasingly depleted. So this is important to understand. As well, natural resources, some of them are non-renewable resources, which I'm sure you heard in biology class and other classes. So coal, oil, uranium, these are finite resources that cannot be renewed or reused very easily, and we will run out of dependent on our usage. And so development overall is defined as an improvement in human well-being through economic advancement. And so this is what we define development as. So this is just a, in your book, figure 1.10. This is an important figure to understand. And so in the green we see people resources used by people in developed nations, and in the tan or whatever color this is, resources used by people in developing nations. So the green is only 20% of all of humans, or yeah, 20% of all of humans live in developed nations. So that means 80-ish% live in developing nations. So 20% of Earth's population has 87% of the automobiles and trucks. Right? 20% of human population eats 45% of the meat and fish on Earth. 20% of the population of Earth use up 58% of the total energy, and then paper is an unbelievable percent for paper as well. So small percentage of people using up the majority of resources. This is quite remarkable. So we can study historically what has happened when people use up too many resources. And so this is Easter Island. And Easter Island is an island that, oh geez, I think it's off the coast of South America, if I remember correctly. Anyways, I think the west coast. Anyways, Easter Island, basically what we saw is that this used to have tons of trees, and people used to live here. They made these funny looking statues, and they cut down all their trees for a shelter, and then also canoes for fishing and such. And what happened was soil erosion occurred, because you need the trees to keep the soil sort of intact. And then that depleted the soil from nutrients and such, and so then they couldn't grow crops anymore. And so literally this population either migrated or went extinct. I can't remember which, but it's no longer. This island is not a functioning ecosystem and no longer can maintain human life on this island. So that's what happens when resources are depleted to such a degree that you don't have a functioning natural ecosystem. So what we want to do is we want to, instead of just bringing economic well-being, we want to have human well-being depending on sustainable practices, something that's more long-term. So sustainable development is a key term that you should remember, and this means that development that balances current human well-being and economic advancement with resource management for the benefit of future generations. So through sustainable development, we can maintain Earth for a long period of time, and we can manage our resources and even help people grow economically and just their overall well-being. I just mentioned this book. We'll talk more about it later, but Radical Simplicity by Jim Merkel. This is an unbelievable book, and he talks a lot about this idea of sustainable development and making sure we have enough for future generations and current generations as well, resources that is. I can't remember why I put this slide in the PowerPoint. I think people riding to work, and so they're using a more sustainable practice, one that they're not using fossil fuels like these people in the background, which is not a resource that can be maintained through time, but bicycles and using human power can. And so here's 3 concepts that you should understand in order to live sustainably. Environmental systems must not be damaged beyond their ability to recover. So you can't damage an ecosystem to a point where it can't recover anymore. That's very important for sustainability. Renewable resources must not be depleted faster than they are generated. So we must maintain and be careful with renewable resources, fresh water, and that sort of thing. Non-renewable resources must be used sparingly. So fossil fuels that are non-renewable, we should be careful and use them in a way that can be extended for a long period of time. Defining human needs. So do you need Electricity. Do you absolutely need it? That's a big question that you have to answer for yourself. So people in developed nations might say that they need electricity, but is that actually true? Can you survive without electricity, right? Uh, Whereas I actually just watched a documentary where I saw individuals from Sudan that had never even seen a light bulb or electricity or a toilet for that matter. And so these modern conveniences, some people in the developing world, these modern conveniences, they have never even heard of. And so what is human basic needs? Well, here they are: air, water, food, and shelter. Right? We survive off of these basic needs, and so that's all we really need. We don't need anything further, and so we can live sustainably if we just meet these needs. And hopefully, we want to use electricity, but maybe we can do it in a more sustainable way. Ecological footprint. So we did this the other day in our ecological footprint activity. We'll talk more and more about this, but this ecological footprint was proposed a little. Oh, geez, I'm blanking on the guy's name. William Rees and a grad student, Mathis. I forgot his last name. Back in 1995, and what they wanted to do was measure how much usable land is there for resources on Earth, right? And they calculated that. There's I'm blanking on the number. I remember our footprint, but anyways, I gotta hurry here. The measure of how much each person consumes expressed in area of land. So they calculated how much area of land do we have to use, usable land on Earth, and then how much do you use or how much do humans use currently. And so this is sort of a diagram that shows you this. There's a percentage of what you use, your footprint, that goes to energy needs, settlement needs, timber and paper needs, food and fiber needs, agriculture, right? Fishing needs. This makes up your footprint. And so how much is your footprint devoted to energy needs? How much of it is for food needs? This is a question, and you can measure this in terms of land area that you consume, and this is called your footprint. So present day footprint of global human population shows this foot that's larger than the Earth. In fact, they've calculated that we're about 125% of Earth's total usable land area. So we're beyond the capacity of the Earth's usable land. And you can't sustain that for very long. You start to stress out systems too much. This would be the footprint of global population if all had average U.S. lifestyle. So we would need 5 or more Earths to sustain us if everybody on Earth, the 7 billion people, lived like the average American. You calculated your footprint. You saw how many Earths they would need if they lived like you. So we should think about that, and we'll talk more about that. Now, India and China are catching up to us. They're becoming more developed, using more technology, more fossil fuels, and therefore their footprint is getting quite a bit larger. This is going to be a challenge because they are the most populous nations on Earth. That's the end of part 5. We're going to finish up part 6, and that's going to be science as a process, and that'll finish off chapter 1. And so part 6 will be the last. This is the end of part